Alright, let's consider a function y is equal to x cubed minus 6x squared plus 11x. Find the critical numbers, find the absolute maximum and minimum values on the interval of x is greater than or equal to 0 but less than or equal to 4. Okay, so let's find the critical numbers first. So to find the critical numbers, we need to let our derivative function dy over dx is equal to 0, right? I'm just going to let that equal 0, right? So let's find our derivative function, dy over dx is equal to 3x squared minus 12x plus 11. Okay, and I'm going to just call this f prime of x. It's just easy to do substitutions. And now what I'm going to do here is I'm going to let f prime of x equal 0. So if I let f prime of x equal 0, then basically, I'm just going to separate that. Okay, so if I let f prime of x equal 0, then I get 3x squared minus 12x plus 11 is equal to 0, and then I'm going to factor this guy out. Okay, now you can notice here that this doesn't seem like it's factorable, right? You want two numbers that multiply 33 that add up to negative 12. It doesn't seem to be factorable, so what you could do here is you could use the quadratic formula. So the quadratic formula is x is equal to negative b plus minus b squared minus 4ac over 2a. Okay, so if I plug this in this case, negative b here is negative 12 plus minus b squared is basically negative 12 squared minus 4 times 3 times c, which is 11, and this is over 2 times 3. And if I plug this in, what I'm going to get here, so you get 12 plus minus 144 minus 132, and I'm going to divide this by 6. Okay, so x here is equal to 144 minus 132. So I get 12 plus minus square root 12 over 6. Okay, so I'm going to get two values here. Okay, so one of the values is 12 plus square root 12 over 6. And you could simplify this, right? You could simplify this as 12 plus, this is basically going to give you 2, 3, 6. So I'm just going to cancel this out, right? So this is a 6, so this becomes 3, 6. I'm going to divide everything by 2, right? So you're simplifying it, right? So one of your values is 6 plus square root 3 over 3, and the other value is 6 minus square root 3 over 3. Okay, so those are our critical numbers, and we want to find the absolute maximum minimum values on the interval. Now they do use the term absolute here, right? Normally when you have a degree of 3, you just think about local maximum minimum points, but because you're given an interval, yeah, you could use absolute maximum minimum. It's okay, right? Just terminology. And all we have to do here to find the maximum minimum points, we just have to plug it in, right? So one of your points here is f of 6 plus square root 3 over 3, and the other point is f of 6 minus square root 3 over 3, right? Now because we want to keep exact values, we can understand that this is basically 6 plus square root 3 divided by 3. You'll get 2.577, right? In this case, we get 6 minus square root 3 divided by 3. We get approximately 1.423, right? So you can notice that I had to kind of round these off. So it's preferably better if I just kind of keep it in its radical format, right? So you can leave your answer as 6 plus square root 3 over 3 and f of 6 plus square root 3 over 3, because of the fact that, right, these are not going to be these aren't going to be whole natural numbers, right? That they are going to be rational to some extent. So 6, and the other point is 6 minus square root 3 over 3, and f of 6 minus square root 3 over 3. Okay, so one of our points here, I'm going to change the colors. One of our points, this is going to be our absolute maximum. Okay, so this is our absolute maximum. Right, and the other point here, let's call it this guy. Okay, and this guy is going to be our absolute minimum. Okay, and that's basically how you can use a first derivative test to determine the absolute max and absolute minimum points of a function within this given interval. And you can notice here that this was a little unorthodox because of the fact that we couldn't actually factor the derivative function. We had to use a quadratic formula. But it's always better to kind of be exact in terms of mathematics versus rounding it off. So I've left it in its exact state, basically.